back to another one of our meetings. Just real quick before we get started here, I kind of want to make a couple of announcements. So for the eBoard interns, we're still looking for interns to help us with this semester and then for the next semester. So as a reminder, the application's due on the 27th. Graduation stools, if you're graduating this year, if you want a CSS stool, make sure to check the Discord. It'll be due on February 25th. And then just about CSS, the mentorship program. If you're interested in becoming a mentee, the deadline is today. For mentors, it's going to be on the 20th. But if you are interested in the program, and if you want to be a mentee, it's going to be due today. All this information, Keaton's just sending it in the chat, but you can also find it, in our Discord. Okay, Keaton, I'll let you take it away here.
Yep, go ahead and take it away.
Okay.
Yep.
I'm going to go ahead and share screen. Let's see. Share. Is this all visible for everybody? Just let me know if it isn't.
Perfect.
Yep.
Fantastic. All right. So first off, I'm sorry about the whole UCR template's the only thing I have on hand. I am currently a PhD student at UC Riverside. I'm an alumni from the year 2018, the class of 2018, from Cal Poly Pomona. My name is Carter Slocum. Mostly going to be talking about American STEM PhD programs, why you would or would not want to apply for one, just in case anybody here is interested. Yeah, that's pretty much what it's going to be. The first half to 1/3 of the talk is going to be that, and then I have slides from my conference presentation talks over the last year that I'll be going through just to fill time until we do Q&A. I do need to be out of here by 1 o'clock though, because I've got some meetings that I need to go do. Also, I was planning on doing this talk for CSS like 2 years ago, but then like COVID hit and a bunch of weird stuff happened, so it's been kind of delayed. But yeah, so as far as who I am, I was the CSS president from fall through the end of winter of 2018 when Daniel Hilsberger took over for the last quarter. So this is a picture of me from 2015 back in the end of freshman year. So as a side note, guy with the sunglasses in the center of the picture, that's Max Wolotsky, who became CSS president back in 2016. He's finishing up his PhD at Georgia Tech right now. He's in cybersecurity. He did all of his undergrad research with Professor Hussein. It's off on the left there. I don't believe anybody else pictured in this photo did their PhD program, but I know that there's a Paul Sewen who's doing his PhD at USC, who's at the same year as me. But he focuses more on like accessible web technologies. So as far as like my bona fides really quick, CSS president for 2017-2018. I'm a 4th year PhD student at UCR. I've done work, I did about a year of software engineering at Northrop Grumman in between graduating undergrad and starting the PhD program. I've also done internships at JPL, Ames Research Center, did some research at Harvey Mudd College over one summer. That's about most of my work history. And then I'm basically in this PhD program after leaving Northrop Grumman because I didn't really like the whole 9-to-5 grind, but also because I had the PhD program applications ready to go before I even started working there. So just some quick publications. The end of this talk is going to be mostly covering the top 2 publications, which are the ones I'm first author on, the ones I did like all the work on, other than getting a bunch of help with experiments and writing the paper. I've helped out on some papers with Shukan, who's the main colleague that I worked with back in 2019, 2018. Might talk a little bit about those, but I don't have full presentations on them. And then I also have another paper from back when I was doing research in undergrad to prep for the PhD program. But speaking of PhD program, what the heck is it? So a PhD is a research degree. It is not another bachelor's degree. It's an extension of whatever you did in your bachelor's is what mainly qualifies you to go further on. It's not a teaching credential. You do go through some teaching training if you go and teach to help ends meet. Like I have to go through teaching training usually at the beginning of the year, but it's not a teaching credential. It doesn't qualify you to teach at a high school. It is not a technical certificate, so you don't get certified in things like cybersecurity. You can go do that on the side, but it doesn't qualify you to like go work for Microsoft. And it's not a master's degree. Even though technically you can petition for a master's degree about halfway through your PhD program, so you sort of pick one up along the way, the PhD itself does not include the master's degree. You need to like just pick it up if you want it. In terms of what the point of a PhD is, there's a nice infographic that was made by a Professor Matt Might, which I'm going to go to right now. So this is the illustrated guide to a PhD. This is how it was explained to me back in my freshman year at Cal Poly, when somebody explained to me what the whole thing was, because I had no clue what a PhD was before this. Professor Ran Liebeskind, who used to be a professor at Harvard, but he's on leave now. I think he's retiring. But he would come by and do a talk at CSS every year and just recruit a student for research. And he explained it to me like this. So imagine that all of human knowledge is a circle. When you do elementary school, you just get the absolute basics. 2 + 2 = 4. The Declaration of Independence was signed in 1776, whatever. It covered a lot of everything, but not very deeply. By the time you finish high school, you've got like the absolute core of human knowledge. When you do your bachelor's degree, you get a little bit more of your general ed stuff, but you got this little bubble here. So for us, this is your computer science degree. You know a ton about computer science, but only really the basics. When you do your master's degree, you pick a part of computer science that's like your favorite and you focus down on that. If you really like machine learning, you go and take machine learning courses. If you like computer graphics, you learn about rasterization and ray tracing and path tracing and Monte Carlo simulation and all that. When you do a PhD, the first thing that you do is you read just an ungodly amount of research papers to figure out, okay, well, where is the absolute edge of what we know how to do in this area? And that's how you get to the edge of the circle. And then the actual PhD, what you do for 5 years is you push. You just look at that edge and you say, what can I do here? How can I push at this? How can I come up with something new that nobody else has done that's actually useful? And after a little while, you find something and you make a little bit of progress. And congratulations, you've got a PhD. But it's really, really small compared to the sum total of human knowledge. So you got to, keep your ego in check. But this is basically what it is. The whole point of a PhD is to discover new things, perform new research, share it with everybody, and move human knowledge forward. That's sort of the romanticized idea of what it is. But if we go back to the nuts and bolts of it, the main misconception people have about a PhD is that it's the master's degree plus. It's like more advanced. You just go back to school for way longer than a master's degree. And there's a huge difference between the two. A master's degree, it's very hard to not get into a master's degree. If you apply at Cal Poly here and your grades aren't atrocious, you're in. Like there's very little to get you kicked out of the program. But you got to pay them for the next 2 years until you're completed with your degree. A PhD is really difficult to get into. Most people get rejected. Most applicants get rejected for PhD programs. But that's because the university and the federal government pays you to go get your PhD. I make a salary by doing this. So it's not a lot. It comes out to about minimum wage. So you don't make a ton. But the main misconception is, okay, a master's degree is 2 more years of school and you get a better degree. A PhD is a job. It's a job application that you fill out and you get a job and you go do research as a job. And also you take some classes at the same time. So that's what I see as the main difference between the two. So how do you finish your PhD? It's so dead simple. You walk into a room, you find 5 experts in your field, and you say, hey, can I have a PhD? And they say yes or no. It's that simple. You just need to convince 5 people to stake their entire, career and reputation on you deserving this little title at the end of your name. And that's a huge ask. And because of that, they've set up this gigantic system that takes forever to go through and is incredibly difficult to actually complete, because convincing people to stake their whole reputation on you and your research takes a while. So even though all you really need to do is defend a thesis and convince people you should be a PhD, the way you go about and do that is a lot more detailed. So in general, what you'll do is after you get in, you will either be assigned an advisor or you will go visit several different labs over the course of a year. And by the end of the year, you will pick an advisor. Most university systems, especially the UC system nowadays, is you are just given an advisor the second you walk in. And if you're going to swap, you got to do it within the first year. You take about 1 to 2 years of graduate level courses. These are the same courses that a master's student would be taking. But whereas a master's student just needs to pass these courses and then take an exam at the end and they get their master's degree, you need to pass these courses, take an exam at the end, and do an oral presentation on some research that you did while you were taking those courses. And that's called your qualifying exam. This is the main spot that PhD students get kicked out. I mean, kicked out is a mean word, but it's the main point where they just leave. If you can't pass your qualifying exam, which usually happens about 2 years in. I finished mine just as COVID hit. I had to do it remotely, which was really annoying, actually. But got through all that. At that point, if I wanted to, I could go, if I decided I wanted to leave the PhD program, I could walk up to the department and say, hey, I passed my qualifying exam, but I don't want to do a PhD anymore. And I could fill out a petition. They would hand me a master's degree and I would just leave. I didn't do that because I wanted to do the whole PhD. From that point on, you don't need to take any more courses at all. You need to go work for the university and do research, and that's it. You do a certain amount of publications, depending on the STEM field you're in. So for computer science, the standard is 3 or more publications, and then you do your thesis. If you're in something like medical field, it can take you 6 months to grow a piece of tissue that you're trying to do your experiments on. So the expectation is you maybe get 1 paper out, or you have at very least gotten a couple of articles out about a theoretical paper. So depending on your field, it will differ. But for computer science, our experiments are really fast and we're expected to crank things out pretty quickly. So 3 is usually good. Then you propose your thesis to a committee of PhDs and they say, yes, you can work on this, or no, you can't. And then you write your thesis, you complete your experiments, then you defend it again and they say, yes, you can have a PhD, no, you can't. And if they say no, you just try again the next year or leave. I'm 2 first author papers and 2 second author papers in. So probably in fall, I will be defending my thesis. So I'll be graduating next year, if everything goes well. So that's what a PhD is. Why would you do this? Okay, if you ever want to be a professor at a university, especially in a STEM field, it's required. You might be able to teach, there's plenty of professors at or I guess you'd call them professors at Cal Poly Pomona. So Nima Devarpama doesn't have a PhD, fantastic teacher, but he not a full professor. But then you have people like Hussein or Sang or Tang who are full PhDs and are full professors and are going to be there forever. And that job does require a PhD. If you do work at a research lab, the vast majority of people have PhDs, but they're a little bit more flexible. So if you are just some sort of machine learning wunderkind and you want to skip the whole PhD process, but you only ever want to work in industry, you could go send your application to DeepMind or OpenAI, and if they really like you, they'll hire you. And it doesn't matter if you have the degree or not. But that's really hard to do, and 90% of them have PhDs or are working on PhDs. The nice perk of having a PhD is the PhD is a license to basically go work on whatever you want to go work on, as long as you can get funding for it. So if I want to go, pivot from my current focus, which is computer vision and graphics, and I want to go pivot to human interaction in video games or something, wildly different, I can go do that as long as I, can secure funding for it. I basically get to pick on So I want to do. The benefits are fantastic. Tenure is probably the strongest job security of any job in America, bar like a police union or something like that. You are locked in, you get great benefits, you get health insurance for your whole family. It's like really solid. The pay is not as good as, say, lead engineer at Google, but it's solid pay. You get to call yourself an expert in whatever it is. PhD has a lot of prestige thrown at it. And you basically get paid to read papers and learn stuff and create new things for a living, which is, if you're really interested in that sort of like fantasy, then this is how you do it. And the hours are flexible. The downside to that is you got to do a lot of hours, but you do get to choose them. I have never filled out a punch card at all doing a PhD. You don't have to log your hours or anything. You just got to come up with results at the end of the week. So if you are like me, and my productivity varies from day to day, where I will wake up on a Wednesday and not be feeling it, and I will just put in 10 hours on a Thursday and make up for it. This is a good way to go about that kind of work. Why not do a PhD? Oh, there's so many reasons. Let me tell you. You're going to make minimum wage until you graduate. The only way to not make minimum wage until you graduate is internships, which distract you from your research. But I mean, in computer science, internships are all over the place and they pay really well. So generally what you do is the minimum wage will pay you to survive for the year. But if you want to get like guacamole on your burritos or buy a Nintendo Switch or whatever, you go get an internship and you'll be set for the next 4 years or what have you. A PhD does let you choose what you want to do, but because you have to do all of your research under a different PhD before you get yours, what they say you have to work on is basically what you have to work on. So you don't get that freedom until after you've completed your PhD. Your minimum wage until you graduate, your first 2 years are usually fully funded by the federal government and the university. It falls off at that point, and you are expected to make up for that by either convincing your professor to straight up pay you out of their grant money or teach. You can get hired to TA, or even later on, like you can get offered instructor positions. So basically do what, Gershman does at Cal Poly Pomona part-time to, get some extra cash. The other downside of a PhD is it straight up takes 5 years or more. If you come in with a master's, you might be able to do it in 4, but the national average is 5 to 6 years. It's long. If you want to move on with some other part of your stage in life, if you planned on retiring by 35 or something, it's not going to happen, and it will take a while. There's a culture of publisher perish in PhD work. You need to get papers out or you're not making progress on your career. The only measure of progress of a PhD is how many papers you get out. So if you don't like writing papers, don't get a PhD. Your hours are super flexible. I'll have weeks where I have like nothing to do and I'll just be exploring and reading papers, and the hours are incredibly light. And then I will have like a 2-week period once a quarter where it's, a 60-hour work week trying to get a paper out. Like there's some crunch involved. Ideally, you and your professor have an understanding about what days are good work days. Like I have a good relationship with my professor where unless we literally have a deadline on Sunday, we don't talk to each other on the weekends, period. Weekends are for rest. You do not work on those. Not all advisors see it that way. Make sure you talk with an advisor and make sure that you have your work hours expectations figured out. More reasons to not do a PhD. Your advisor is probably the most important factor. If they force you into an area of research that you don't like, an area of research you don't think you can get published in, if they expect you to come into the lab 9 to 5 in addition to the weekends, or some other unrealistic work hours explanation, you got to like leave or knuckle down. It's very, draconian in that way. The other thing is imposter syndrome. You're working with world experts in their fields, and you are not yet a world expert. You're becoming one, but you're going to walk into a conference where everyone knows what they're doing more than you. for at least the first few years. And there's like a psychological toll to that. You need to be okay with being wrong, because really I have work meetings tomorrow, and it's going to be me and two PhDs who've been doing this kind of work for 30 years. And they're just basically going to tell me what I did wrong all week. You need to be okay with that. They'll also tell me what I did right, but they know their stuff. There's this unspoken weirdness about, especially at R1 schools that are not the Ivy Leagues, that the majority of STEM PhD students are international. So if you're an international student, you might think, oh, great, that I'll find, a great group to work with. What that actually means is you have a lab of my lab is 3 people. I've seen them go as large as 10. MIT labs go larger, but at the UCs, they're usually around that size. You will probably be the only person from your country in your lab. You will have communication issues, cultural issues, and you will need to be comfortable working with all of that. And it's like really interesting and fun sometimes, but it's also frustrating if you're trying to get, communications about a paper done on a deadline. You need to be okay with, making a reference to some Marvel movie and people just not knowing what you're talking about, basically. It's hard to move forward with your life goals. If you are planning on getting married, get married before the PhD, and make sure that is, a rock solid relationship. If you're having kids, have them before the PhD. Make sure that you've got the whole plan set up, what preschool they're going to go to. You've got the whole savings fund ready to go before you try and do the PhD, because it's going to be 5 years of you making a little bit above minimum wage, and it's going to be hard to move other life goals forward. Anecdotally, you might lose your hair. That's just been my experience. I don't know if that just comes with the PhD or if it's just my dad's terrible genetics. In terms of what a successful PhD student looks like, if you ask a professor, they'll say things like, oh, they know what hours they work really well in, or they keep a journal or what have you. In my experience, it's actually much more dull. It's, okay, did you come in with $100,000 of debt and no plan to pay it off? You're probably going to leave in 2 years for a job at Amazon because you need the money. If you're solid and you are okay with making minimum wage for 5 years, you're probably going to do fine. Are you comfortable working across languages and cultural differences? This is going to be true even if you go work in industry, but it goes double for PhD. You need to understand, be patient, and be very flexible with your communication. Are you comfortable with being solid in a rock solid relationship or being single? It's very difficult to go about moving your personal relationships forward during a PhD. Most of the people that I hang out with are people that I've been friends with for 5 years and not people I met within the last year, right? Stuff like that. Granted, that might be COVID, but it's just been sort of my experience. And besides being good at research, the point of the PhD is to get papers out, which means it's all communication skills. If you can't communicate your cool new ideas, your amazing experiment results, then they may as well not exist. So your ability to write a technical paper and to do these kinds of presentations, half the reason I'm doing this presentation for CSS is so I can get practice talking and giving presentations. That's the core skill. The admission process is really straightforward. It's kind of similar to applying for a bachelor's, but with extra steps. You get your transcripts from your bachelor's institution. You get a statement of purpose, which you write up custom to whatever institution you're applying to. You get letters of recommendation, preferably from PhDs. Don't get your letters of recommendation for someone who does not have a thing that says PhD at the end of their name. It'll just get ignored. Your GRE is the least important part of this. Like, wing it. Nobody cares. It's the SATs. Nobody cares. You will do some interviews. You will visit your labs. I visited UCR, UC Irvine, and USC. I was planning on visiting Stanford, but they rejected me so fast I didn't even have to. Woohoo! The admissions decision will come in basically today till mid-March is when admissions decisions come in. So I've got Twitter open on my phone and it keeps buzzing with like random people that I know saying, hey, I got into whatever university. Okay, but that's just the materials you need to assemble. How do you actually get into a PhD program? I have never met somebody who got into a PhD program who did not have their name on a publication in a scientific article, or had worked on a lab that had people with publications. The reason to do a PhD is to do research. The way you get in is with research. It's like applying to become a shoemaker and you say, well, I've never made a shoe before, but I want to learn how to make shoes. And then somebody else comes in and says, I want the same position, but I've made shoes before. Here are my shoes. They're going to pick the other guy. There's three ways to do this. There's some of the professors at Cal Poly do research experiences for undergrads. This is the main reason why you should go do them, is because it'll make you an incredibly strong PhD applicant. You can also do your research at other institutions. JPL has research scientists who need undergrads to help run experiments. You'll get your name on a paper. Woohoo. You can go talk to the professors at Harvey Mudd. They're always looking for undergrads for summer internships. I would give you Prof. Ron's contact info, but I think he's retiring. So maybe talk to Jim Berkowitz or Professor Zachary Dodds at Harvey Mudd. Just give them a cold email. They'll ask you for like application materials. The intern at a research lab is a little bit more difficult. Like Lawrence Livermore is pretty common, but they're a little bit more difficult to get into, and they're more competitive because you'll be competing with like, the Stanford dorks to get into that. The shoe-in way to get in, if you get a professor at the university that you're planning on doing your PhD at to vouch for you, you're in, period. It doesn't matter what your application materials look like. If the professor vouches for you, you're in. The only way to get them to do that usually is to show them your research work and to convince them that they should take you on as their PhD student, which is kind of difficult to do. I have a friend who's doing her PhD in mechanical engineering, aerospace engineering, and she wasn't planning on doing a PhD, but her boss at her old job left to become a professor because he had a PhD, and just said, hey, do you want to go do a PhD? And she said, sure. And now she's 3 years into her PhD program. So that's the end of the PhD portion of the talk. If we want to do like a quick Q&A session, I can round out the last 20 minutes with just what my research has been on. But do we have questions immediately? Because we can just go do those.
Carter, I have a quick question. I know you're talking about like the difference between like a master's and a PhD. So in terms of like, I know for like some masters you do have to take an exam, but some masters you do actually have to write a thesis. So like, based on your knowledge, what would be the difference between a master's thesis and a PhD thesis?
So one thing I should have said at the top of this whole thing is that every single university has slight differences in how they do their programs, both in their master's and their PhD program. I can really only tell you how UCR does theirs. So at UCR, you have three options for your master's degree. You can do a written exam, you can do a project presentation, or you can do an oral exam. The way that the computer science department does it is that when you take your final, because you have to take at least a year of courses, when you take your final, they have 1 or 2 questions at the end of the final that you can opt into that count as part of your written and final exam, your qualifying exam. So you actually just take your qualifying exam slowly over the course of about a year and a half. And by the end of it, you've taken your written exam. You don't have to like walk in and take, a 5-hour-long exam for 2 days. The other way to do it is you can do research with a lab and complete your master's that way. Typically, master's students don't do this unless they're planning on transferring into the PhD program. They basically start with a master's degree, look at the PhD work and say, oh, I want to go do that with my life. And they do a project presentation or oral exam to go do that. So you can do both. Most master's students just take the written exam and finish off there. PhD students have to do both.
Okay, got it. Thank you.
Anybody else got questions? All right. So I probably only have time to do one of these 2 conference presentations. So one of them is computer graphics on the web. So web-based VR. And the other one is accuracy testing for mobile augmented reality. Does anybody have like a preference which they would like to hear? No? Okay, let's do the Web 3D one because that one's fast. All right. So SIGGRAPH is the big computer graphics conference. They do this at the LA Convention Center. Actually, if they do this at the LA Convention Center next year, and those of you who are still around want to look at a huge industry or research conference, volunteer to be a student volunteer. You basically do 40 hours of student volunteering over the course of the week, but you get an all access pass to the conference. You don't have to pay a cent. Highly recommend it. This is Web 3D, which is their spin-off conference, which is entirely remote because I couldn't get into the main conference. Darn. But VIA, which is visibility aware web-based virtual reality. I presented this back in December at the Web 3D conference. So WebexR is a set of technologies built on top of WebGL to enable VR and AR over the web. You will like literally click onto a website on Google Chrome and a VR app launches. It's basically what it is. It's based on transferring graphics data using the GLTF 2.0 format. This GLTF is essentially a giant JSON file or JSON-like file that stores things like, it's accompanied with a giant binary file, which is just raw ones and zeros, and says, okay, these ranges stand for the vertice locations. Here's some animation data with like Bezier curves or what have you. Here's what textures get mapped onto these 3D models. All that information in a giant JSON-like description file. This is all done by the Kronos group. This is the same people who do OpenGL, if you're familiar with that. This is all designed so that you can run these huge 3D applications on the web. So one of the problems with the GLTF format is that it will load things really slowly over an internet connection. So it takes a while to load things. If you've played a video game on a console or what have you, you'll wait like, what, 4 to 8 seconds or something for a loading screen for a level. Imagine trying to do that over your internet connection rather than over a hard drive. It takes minutes. It takes a while. So we did some testing. We ran this over big production level 3D scenes, and we just measured how long it took to load these over different network connections. So your fast 3G, which is your mobile network. So if you're not tethered to Wi-Fi, this is how long it would take to load these scenes. It takes like 250 seconds, multiple minutes, super long. A 10 megabyte per second connection is the slowest Ethernet connection you could think of, or the fastest wireless connection you can think of. So 5G basically is what that is. And then you have 30 megabyte per second, which is your home router usually is about what you would get. So these are incredibly long load times. How can we speed this up? So typically what happens is the client will connect to the server will send back a GLTF file and the raw binary for the whole scene. You need to download both of these and all the little texture images before anything gets rendered. You need to wait for a big GLTF file, a big binary file, and anywhere from like 1 to 50 images to get downloaded before anything gets rendered in 3D. So this is why you're going to be, you put on a headset, you're going to wait 2 minutes for something to generate, which is way too long. So one of the ways to go about this is to break up this monolithic binary file. Second problem. So the first problem is that there's a giant big thing that you need to wait on for it to render. Second problem is that even if that wasn't a problem, it renders all this stuff in a random order. Basically, when you model all this stuff in, say, Blender, and you export it into a GLTF file, it just does it in whatever order it prefers. Usually the order that you created the objects in when your artist was modeling the whole thing. And those objects might not be visible given the initial view. If you're standing on this balcony of the shack in this scene and you're staring out at this satellite on top of a mobile home, that satellite is something like the 47th object to get downloaded, and therefore the 47th one to start rendering. But the roof, which you can't see, which is behind you, gets downloaded like 5th. but it's completely useless because you're not going to be looking at it for a while. So 2 problems. All this needs to be downloaded before any of it renders. And even if that wasn't a problem, it would render in the wrong order. So let's solve both of those. We can solve cause 1 by taking that big binary file and chopping it up to hundreds of small files. Rather than say we have a ground object, which is pointing at to part of the binary file and a bunch of images. And we have a satellite objects pointing to several different parts of the binary file and an image. And you need to download all these before anything happens. Let's chop the binary up so that we can get the satellite object first without having to download the entire binary, get its associated images, render it, and start working on the other things like the ground, the wall behind you, the skybox in the sun that you can't see because you're looking away from it right now. You can get all that later. How do we do this? Well, first off, we parse through the whole GLTF and we build the scene and we get rid of everything that's out of view. Just a view frustum calling. If you take an intro to computer graphics, you probably know how to do this. It's a bunch of just, what side of a plane is this object on, and then do some quick, bit manipulation to do that for 6 planes instead of just 1. Heuristic 2. Okay, even if you're out of view, the ones that are just barely out of view should be higher priority than the ones that are completely behind you because of the way you move your head. I don't instantly flip 180 degrees. I have to slowly turn my entire head over. So things that are barely out of view should be somewhat high priority, whereas things that are completely behind me should be the last thing that ever get downloaded. So quick thing we do, we score all the objects using this view frustum calling and rotation heuristic, combine those to get a score for all these objects. And then we do data buffer grouping, which is to take that big binary file and chop it up into little bits. There's some weird technical stuff you need to pay attention to, like making sure that you do your rotation scoring correctly, don't make any math mistakes. You need to make sure that your binary file has like byte alignment, which is a thing that's important for making sure that it runs well on a GPU. Little data things that aren't super important, but the output of this is a bunch of little binary files numbered from 0 to n in order of the priority that they should be downloaded in, and the associated images with those. So when we run this experiment on those initial scenes that we did our initial check on, we found 5 of these scenes. Some of them are outdoors, some of them are in outer space, some of them are indoors. We ran this on 3 different network bandwidths to see how much improvement we could get. And so we found a couple things. Compared to the control, it is always better to chop up the binary into little bits. Sometimes it's good enough to leave the binary whole and just prioritize which images you get first. So you always get a strict improvement over the control by chopping up the binary a bunch and prioritizing which objects you download. But sometimes you can just leave the objects as they were and just prioritize which images you get. The amount of improvement is highly dependent on what your initial view is. So if I have a view out on a vista and I can see an entire city, I need to download the entire city for the first view to be correct. Whereas if I'm standing on a street and looking at one building, I don't need to download the rest of the city for it to be correct. I only need to download the one building. So the amount of improvement using this scheme depends on where you start. You also get larger improvements over the control on the slower networks. So if your network is lightning fast, you're barely going to see an improvement using this scheme, maybe a few milliseconds to a second or two, depending on how big the scene is. But if you're running on like 3G, you could cut minutes off of your loading time by doing this. Highly dependent on initial viewpoint. Oh, whoops, I got ahead of myself. Yeah, highly dependent on the initial viewpoint. If you are forward in the scene, that is to say you only have, say, a tree and like the ground visible, you're gonna cut your load time by 75% more, insane amounts. If you are in the center, meaning you can see about half the objects in the scene, you're gonna only cut down by maybe 40%. And then if you are all the way back and you can see every single object and you need everything to be downloaded anyways for the view to be correct, then you will actually just not get any improvement. And in fact, there'll be a little bit of overhead. So if you know for sure that you need everything to be downloaded for the view to be correct anyways, don't even bother with this. But if you know that there are some objects that are out of the initial field of view, then you'll get some improvement. To make this VR specific, we need to know that if I've got a VR headset on, what will happen is I will hit load and I'm bobbing around, I'm shifting my weight. I might hear my dog in the other room and I might turn around to yell at it or whatever. And when the view finishes, my head might be looking somewhere else than when I initially started the loading. So because I'm prioritizing all the objects in my initial view, if I turn my head, that's no longer my initial view. So this could potentially be an issue with our prioritization algorithm. So we ran some experiments with, okay, as I rotate away from the initial view, how much worse does the algorithm perform? We found that we still beat the control until you look further than 90 degrees away. So if I turn all the way around, I'm penalizing objects that should be going first, and the algorithm is worse. But as long as I don't completely turn around, I'm still beating the control. So it's robust to that sort of issue. That's the end of this presentation. I also have one on augmented reality accuracy, but I don't think we really have time. Well, I don't really have time. I need to prep for a meeting, but I do have about 10 minutes for questions on that. I can also answer questions about things like job interviews, the big four. I did the full on-sites at YouTube and at Facebook, working at Northrop Grumman, working for government stuff.
I had a question. So what are the routes for a PhD graduate? It looks like the prevalent routes are like being a professor, working in research.
Jobs.
Yeah. Are there any others from those two?
You have three options. Well, you really have two options, but there's three options. So one thing you can do is you can go be a full professor, which means half your time you spend teaching, half your time you do research. That's like the main job that people go for. But over time, the amount of PhDs being issued has increased and the amount of available professorships has stayed about the same. So those are getting more competitive over time. That's still probably the ideal job just because of how secure it is. You're going to get tenure, you're going to be set. But the other two options are industry. I want to say at least half to maybe 3/4 of the people who get their PhDs from UCR go work in industry. So they get hired by Google, they get hired by, I guess they're called Meta now, to go do, AI research for them. They get paid, gigantic 6-figure salaries to go do that. But they change jobs every like 4 years. So it's, less job security, huge payday. The third option is if you want to take it easy, you can just go be a teaching professor. You don't get tenure, so you don't get that, rock solid, I'm set for forever tenure, but you get paid pretty well. I think it's in like the 80K range for state schools if you do full-time. And you get health insurance and the whole thing, but you don't get funding for your research and you're not expected to do research, which is nice because it means you can cut down on your hours. So if you just want to work like 30 hours a week and make a solid paycheck, you can go be a teaching professor. That's not as common and most people don't go for that, but it's an option because universities need teachers who are qualified and, not everybody wants to crunch for 60 hours on deadlines. Those are the three main things. Also, you can just go get a software engineering job. I mean, computer science is nice because we have the private industry option available. If you get tired of your PhD, you can just go leave and get a software engineering job and make, more money than both my parents ever did combined. Like the economy for CS graduates is fantastic.
So for software, what do you think an advanced degree is essential or important, relevant?
That's what you do. If all you do is software engineering, if you're just building, how to put it, CRUD apps on web services, you definitely don't need an advanced degree. if you're just, building a web page that takes user information, stores it, and gives it back to them whenever they need it, like, what have you, you definitely don't need the advanced degree. If you want to do anything involving computer graphics, computer vision, machine learning, bioinformatics, any of this more advanced computer science stuff, you will have difficulty getting into those jobs without a master's. And if you do get into those jobs, they will pay you to go do your master's because you really need that advanced knowledge.
Another question. I'm not sure if you can answer this, but like if you're trying to go from software to management, do you need an MBA for that? Or?
So at Northrop, they did offer to pay entry-level persons who are interested in management to go do their MBA. The problem with that is an MBA does still require, I want to say like 12 to 20 hours of coursework per week in addition to your job. So it's actually very hard to do. You got to be very motivated to go do it. But it's not necessarily required. It's just that at Northrop, they definitely wanted all their managers to have MBAs. But the nice thing is if you work for a company and they want you to get a master's, they will just front the tuition costs for you. Or at least they should.
Hey, Carter, real quick question. So I know you talked about like a couple of probably the professors that you referenced throughout this presentation. Do you mind, well, one, do you have the names of them? And two, do you mind like, I guess sending a list in the chat maybe?
Let me think. Okay, so for undergraduate research, I know one Prof. Ron Libeskind, but he's on leave right now, so he's not answering his work email.
That's fine.
So not him. Jim Burkwell, who is the department chair at Harvey Mudd, I'll put that. Is it okay if I? Well, yeah. Let me just, so I don't know their email addresses, but you can Google these people. They'll show up on their faculty database. Jim Burkwell. Wait, what? To everyone. There we go. Jim Burkwell. And then Professor Zachary Dodds, who's usually in charge of the undergraduate research program every summer. Usually goes with Prof. Dodds. Those are both the Harvey Mudd people. At Cal Poly Pomona, if Prof. Hussein's still doing the security lab stuff,
yeah,
go talk to him.
Yeah, he's always sending out like opportunities and
whatnot.
Yeah,
so there's the other option that I'm aware of at Cal Poly is Prof. Rahasia, who typically does he does like low-level machine learning or low-level computer vision stuff, like the classic stuff from the 80s, which is still useful, by the way. Like I've got a whole paper that basically says, hey, all these machine learning people are trying to get these results, and you can just get better results by using these old algorithms from the 80s on this new problem. So if he's got funding for an undergraduate, you can go talk to him. I have no idea if he does anymore or not. He's also looking for TAs all the time. If you just want if you want lunch money. I did grading for intro to C++ for a year. And I
nice.
That's
cool.
Paid off my car using that pretty much.
Nice. That's cool.
In terms of UCR, my advisor's name is Sir Jesse Chen. I don't know if she's looking for PhD program or PhD students. She usually only has funding for about 3 at a time. So she's probably waiting for me to graduate before she grabs another one. Unless her new grant comes through, in which case she will be looking higher. If you are looking to do a PhD program, get research done. Like if you can't at least do work in a research lab, publications, the ideal thing, but if you can't get that done, at least do work in a research lab and get their letters of recommendation. But what you really want to do is just go talk to professors that you want to be your advisor at the universities that you're going to apply to. Cold email is not the best, but it's better than nothing.
Yep, definitely. I think that's pretty good advice. So yeah, for anyone that might be interested in the whole PhD sort of route, as our speaker pointed out, getting into contact with these professors is definitely probably a good thing to do, as well as trying to do research and whatnot. So what
Side
I'll
note about
go
Harvey
ahead.
Mudd. Harvey Mudd is not a PhD institution. Can't do your PhD there, but they have programs set up to put you into PhD programs. They're designed to help you get there, essentially.
Okay, yeah. Okay, that sounds good. But yeah, what I'll do is I'll just put a list of this in our Discord and our opportunities chat for if you want to contact them. So that's what I'll be doing. And I guess with that said, is there any other last questions any of you all have for our speaker before he heads out?
We've got another 10, 15 minutes
Yeah.
if we need to.
How does it pay for like the research aspect, like starting salaries, like for machine learning and
Once you're done with your PhD?
yeah, computer vision, machine learning. Like what is like the starting
Usually it's
pay?
in the low six figures. Person I know who went to go work for Amazon is making about 120, which is higher than most professors. So for example, the starting salary for a professor here at UCR is exactly 100. And I think at Cal Poly it's something like 80K. I don't know if they've changed that due to COVID or anything, but you definitely make more money in industry, but you're going to have to change your job more often. You're going to have to move more often. So for example, Prof. Sun, is he still there? Prof. Sun?
Yes, he is.
Okay. So he did a ton of work for Amazon, right? And some startups, and he did his PhD at the same time. And he was making probably bank while he was doing it. I don't actually know what he made. But he was probably making a lot more than he made at Cal Poly. But he started working at Cal Poly, and he had a kid the first year that I was there. And he's like super happy with that because it's just way more stable.
Yeah, I like how you kind of pointed out like the pros and cons, because I feel like, you go through like a PhD, it definitely has its pros and cons, even with industry, which might attract a lot of people. They might not like the whole like, oh, I got to bounce from company to company or that sort of
Man,
thing.
2 hours a day commute to Woodland Hills for my Northrop Grumman job, like I would not have survived another 4 months of that.
Yeah, I feel that.
Well, what I should have done was got an apartment nearby, but yeah.
Were you commuting from Riverside to Woodland Hills?
No, I was commuting from my parents' place up in Lancaster, so up near Edwards Air Force Base.
Oh.
That just took forever. Yeah. That's mostly it. COVID has really harmed the whole PhD thing. We're recovering from it now, but basically nobody was able to go to in-person conferences. If you can go to an in-person conference, they're fantastic. I mean, the big ones are like, huge industry things like SIGGRAPH is like Disney sends all their animators there. They like preview their new films. They do stuff like that. Cutting edge research. NVIDIA says, here's our new VR headsets, like big stuff. And the small conferences are like 12 experts in a niche field who like, hang out and drink wine for a weekend. So even those ones are kind of fun to go to, but COVID has deleted that. We've all just been joining a Zoom call and leaving.
Yeah, no, definitely. Like even, definitely with classes as well, school just in general is kind of like shifted things to a format that we're not really a fan of.
Right. And I've been, so the course that I teach is VR, go figure. And we do in-person lab for that because, I mean, we can't require the students to go out and buy a $300 headset to go do a course. That'd be crazy. So we supply them ourselves and we charge them like $20. And over the course of 2 years, we make enough to buy a new set of whatever the new VR headset is. So that's the course that I've been teaching. We have to do that one in person because it's the only CS course here that requires specialty hardware. And that turned from a 12-hour a week thing to a 20-hour a week thing because I have to stay there for an extra hour after the sessions to disinfect everything. Luckily, we're at the point where the risk for that is gone. It's like I'm more likely to get the flu at this point, just because of everybody who works at the university is triple vaccinated and got the flu shot and everything. But yeah, that's been a little bit rough, but we'll be back to normal hopefully next year.
Yeah, definitely. Good luck with that. All right. Any other lingering questions before we head out? Because I know, it's about to be one. Some of you may have classes. Hopefully that's going well for all of our members returning back into person. But yeah. So yeah, I think with all that being said, thank you, Carter, for joining us for our meeting as former CSS president as well. Must have been nice to come back and speak with the club. And thank you for all the information that you relayed. I think it's very helpful for anyone that's probably thinking, maybe do I go for a master's or should I just go for the PhD itself? So I think that provides a lot of clarification for me and hopefully as well as a lot of our members. And yeah, and to all of our members, have a great rest of your week and good luck with the rest of the semester in person. Bye, everyone.